All right, the Unit 1 Objective 4 notes, we're dealing here with reflections. Now, there's two key ideas that you want to keep in mind throughout this set of notes here, especially on this front page. One of them is this, that the negative sign or the minus sign, what does that really mean? Well, it means the opposite. Okay? Think of it this way. If I have, just the number 2. Okay, there we got a 2. Well, what does this mean? Well, it means the opposite of 2, which in other words means negative 2. Might make more sense when we look at this. What does this mean? So negative 2 is how we normally read that, but this means they want the opposite of negative 2, which is what? Well, positive 2, right? So again, the minus sign basically means the opposite, okay? And then the other idea that we want to keep in mind is that f of x, well, that's the same as just writing y, okay? For example, if I wanted to write down a function, I can say, okay, we got f of x equals x squared. Well, again, this is just the name of the function. It doesn't matter if I call it f of x or if I call it something else, and normally we use y. Okay, so these two things are the same. So again, f of x equals y, and then the negative, the minus sign, just means the opposite. And if we keep that in mind, then these notes aren't so bad. All right, so starting with number 1, let's zoom in a bit here. Actually, we're not going to zoom in quite yet. First of all, negative f of x is a reflection of our function about the x-axis. We'll talk about that as we do them. And then f of negative x is a reflection about the y-axis. Again, we'll talk about that as we're doing them. And then we have a couple of things we want to do on each problem. Let's dive into number 1. All right, so number 1, we've got a linear function. Now, it looks like a quadratic function, but there's no exponent, so be careful, that is a line. And then let's start by graphing that thing. So how do we graph this function? Well, let's see, it's shifted left 1 and down 2. So I'm going to go left 1 and down 2 and plot a point there. And then since my slope is 3, I'm going to go up 3 over 1. And there's a second point, and now I can draw my line. I'm going to get a couple more points just to make sure I get a good drawing here. And then if you want to use a straight edge or something, that's nice, but not necessary. So then there's our line, okay? Now, they also want us to draw this thing. Well, what is that thing? Well, remember, this just means the opposite, and this means y. So they want me to take the opposite of all of my y values. In other words, here, I have the point 0, positive 1. Well, if I change, take the opposite of that y value, that'd be 0, negative 1. Here I've got a y value at positive 4. I want to make that y value negative 4. Here I've got a y value at negative 2. I want to make that y value positive 2. And then we can, flip the rest of the points, but basically we're going to take all these points and put them on the opposite side of the x-axis because that's where my y values are going to be the opposite. And then when we do that, we're going to get this line here, which is just a reflection about the x-axis. Okay, and again, the way that you do that is just here, I want to take the opposite of my y values. All the y values that were positive, make them negative. All the y values that were negative, make them positive. And when you do that, you'll have your reflection. Okay. Before we move on, let's do part B, and we're going to save C for a little bit later. So part B, they asked us to describe the translations of the original function from the parent graph. In other words, how is this thing shifted from the regular old graph y equals x? Well, like we said earlier, it was shifted left 1 and down 2. So left 1, down 2, and then that's it for part B. All right, moving on to our second example here. Now we have a quadratic function. So first we want to graph g of x. And it doesn't matter if you call it f of x or g of x or h of x. Again, those are just the names of the equation. We could replace all those with y if we wanted to. Okay, so to graph this function, let's see, this was shifted just down 3. So I'm going to go down 3. And then there's my vertex. Next, since my a value is negative 2, I'm going to get 2 lattice points by going over 1 and down 2 in both directions. And then I got those 3 points. That is enough to draw my parabola. So it's going to look something like that. Okay, and then the second thing they want us to graph is the opposite of g of x. In other words, I want to take the opposite of my y values. So this point right here is at 0, negative 3. I want to take the opposite of that y value, which would make it 0, positive 3. And I'm going to put that up here. Here I get the point 1, comma, negative 5. I want to make that 1, comma, positive 5. And then negative 1, negative 5 is going to become negative 1, positive 5. Okay? So I'm taking all those y values and making them positive. Another way to think about it, once you know that this represents a reflection over the x-axis, you just want to put points on the opposite side of the x-axis. In other words, this point is 1, 2, 3 units away from the x-axis, so I want to put it 1, 2, 3 units away on the other side. That's another way to move your points. And then we can draw our parabola. It's going to look something like that. Okay? And then for part B, how was this graph shifted originally? Instead of being at the origin, our vertex is at negative 3. In other words, it was shifted down 3 because of that minus 3 right there. So just down 3 is all we want for part B. Okay, and again, we'll save part C for a little bit later. Moving on to the next problem, the linear absolute value problem. How do we graph this thing? Well, let's see. This is going to shift our graph left 3. So we're going to go left 3. And then there's our vertex. Our A value is negative 1, which is basically our slope. We're going to go over 1, down 1. And we can do that as many times as we want because that A value just represents the slope of our two lines. So we got plenty of points right there, and now I can draw my V. All right, and again, we want the opposite of our y values. So all these negative y values here, we're going to flip them up and make them positive y values. In other words, we're going to put everything on the opposite side of the x-axis. So again, this is 1, 2, 3 units away. I'm going to put it 1, 2, 3 units away up here. In other words, my y value for this point went from a negative 3 to a positive 3. This y value is going to go from negative 2 to positive 2. This y value from negative 1 to positive 1. And same for these other three. Okay, and then we'll get those points there, and now we can draw our V for that one. And there is our reflection. So those share a vertex, but it was still reflected. Okay, and then what was the translation from the original parent function? In other words, how did this thing shift? Well, just left 3. Okay. All right, and then one more here. We want to graph our next function 2 to the x minus 3 plus 1. So let's see, normally we have a point here at 0, comma 1, and then that's going to be shifted right 3 and up 1. So right 3 and up 1 is going to put us here at 3, comma 2. Okay. Now, anytime we do a vertical shift with a exponential function, we also want to move our asymptote. Okay, that invisible boundary line that is normally represented by the x-axis. So I'm going to draw a new dotted line because that's going to be our asymptote there. And then remember, our exponential functions always have 2 points, 0, comma 1, and then 1, comma b, 1, comma whatever your base is. So normally I have a point right here at 1, comma 2, since our base is 2. So that's moving right 3 and up 1. So it's going to be right here. Okay. And then we can draw that exponential function and be something like that. All right, and then they also wanted us to draw negative j of x, in other words, the opposite of all of our y values. Okay, so I want to take everything and flip it over. Okay, now since we're reflecting this thing, our asymptote is also going to get moved, and it's going to go from a positive 1 to negative 1. Okay. And then we just got to shift those points. So let's see, this point here is 2 units above the x-axis, so I want to put it 2 units below the x-axis. In other words, the y value of that point went from a positive 2 to a negative 2. The y value of this point is going to go from positive 3 to negative 3. And then now it's going to be a bit of an inverted curve, so now it's going to be curving down instead of up. It's going to look something about like that. Okay. And then part B, well, what was the shift for this graph? Well, we shifted right 3 and up 1. Okay. All right, so there's part B. And then part C, what happened on every single one of these graphs? Well, here we reflected over the x-axis. Here we reflected over the x-axis. Same thing on numbers 1 and 2. So for part C, we don't have to write it 4 different times. We can kind of just put it across the bottom. It was a reflection over the x-axis. That's what happened all 4 times. We don't need to write it 4 different times. Okay, so part C, the answer for 1 through 4, it was a reflection over the x-axis. Okay. All right, moving on. Adjust the camera a little bit. All right, next one. We want to graph this function, which is another line, which is shifted right 5. So I'm going to go right 5. And then since the slope is negative 1/2, we can go down 1 over 2. Or we can go up 1 and back 2. Okay, and then we've got a couple points there. Now we can draw our line. All right, and then the second graph they want us to draw. This time we don't want to take the opposite of our y's, we want to take the opposite of our x's. Okay, so then every positive x value is going to become negative and vice versa. Let's see, the only 3 points that we drew have positive x values, so let's make those negative. This has a positive x value of positive 3, so we're going to put it at negative 3, leaving the y value the same. This is 1, 2, 3, 4, 5, 0. We want to make that negative 5, 0. This point is at 7, negative 1. We want to put it at negative 7, negative 1. Okay. So here, rather than making our y's the opposite of what they were, we're making our x's the opposite of what they were. Another way to think about that is we're putting it on the opposite side of the y-axis. So if we recognize this as a reflection over the y-axis, we can just move the points to the opposite side of the y-axis and then get our sketch. And our drawing is going to look something like that. And then just like before, what was the shift of this graph? Well, just right 5. Okay. Next one, if we want to graph this parabola, well, let's see, it was shifted left 2. So our vertex is right there. And then our a value is 1, so we're going to go over 1 and up 1. Over 1 and up 1. And then we can draw that parabola. Okay, so something about like that. Maybe it should be a little bit steeper. But anyways, that's good enough. And then I want to take these 3 points, and I want to take the opposite of their x values. So this is at negative 1, 1. I want to put it at positive 1, 1. This point's at negative 2, 0. I want to put it at positive 2, 0. This point's at negative 3, 1. I want to put it at positive 3, 1. In other words, we're putting everything on the opposite side of that y-axis. And then when I draw my parabola, I have my reflection. And how is this original graph shifted from the parent function? Well, it was shifted left 2. Okay. All right, and then we can stop there. These are getting kind of repetitive now. As soon as we see h of negative x, j of negative x, we know this is just going to be a reflection over the y-axis. In other words, we want to take the opposite of our x values for all those points. And so what's the answer for part C for this whole bottom row here? Well, it was a reflection over the y-axis. So then we can fill that in. Reflection over the y-axis. That's an S. And then that wraps up the first page.